Assalamu alaikum everybody. Um, Welcome to class. Before I start, just a quick question. Can all of you hear me? Is the voice loud and clear? Okay, very good. Okay. Um, so today we're going to start with chapter 5, which is functions. So let's start with this chapter. Basically, functions are tools that allow you to break your program into smaller modules or smaller pieces. And basically, their main advantage is that they make programming easy for you. So we will first introduce functions, what they are, what their purpose is, and then we will look at some examples of how to define functions and how to call functions. Now, you have seen a lot of C programs in this course so far. Now, most real world problems that you see are actually much larger than the programs that you have been seeing so far, right? Because most of the programs that you see are just a few lines. And generally, when you're writing bigger programs, uh, a useful strategy is what is called divide and conquer. So you break your program down into smaller modules and smaller pieces, and then you write those smaller parts, and then you combine them together to build a larger program. So if it is something which you're going to be repeating again and again, then what you can do is put that inside a module or a function and then use that uh, in your program and work in that way. So uh, C is obviously a very popular language, so it obviously supports this type of a modular approach, and so we will look at how it does that to some extent in today's lecture. Now, the biggest tool that allows you to modularize or divide your program into smaller modules is what are called functions. And functions are typically written by combining functions. So you can use pre-packaged functions that C has already provided you as part of the C standard library. For example, you have been using the functions printf. I said that this is a function. Scanf is also a function. There was another function that was part of the C standard library, which was, I think, the POW or the power function. Now, these are functions which are part of the C standard library. So somebody else has written them, and you are basically using these functions without actually seeing how they do what they do. So their definition is kind of invisible to you, or is not visible, or you don't see it. Um, but what you do actually do in your program is you use them in your program. So these are functions. These are functions which are written in C. They allow you to do certain tasks, and you can do those tasks by what is called calling these functions. Okay. And so we have familiarized ourselves with the rich collection of functions in the C standard library. There are hundreds of different functions that have already been written for us, and we can use those existing functions. Another advantage of using functions is if you write things or parts of your program as functions, uh, other people can also use the functions that you have written. So if you are a master, let's just say, of some area, or you write some program which does something fancy, you can put that program in different functions, and then other people can actually use parts of your program by calling those functions. So you can also do the same. Another thing which is generally recommended is to avoid reinventing the wheel. So what we mean by avoid reinventing the wheel is that if something exists already, then you don't have to build it from scratch. You can use them uh, on your own. You can without having to write new functions. So one example is the printf function. Now this function basically allows you to print text on your command line. This is a function which might consist of hundreds of lines of code, but you don't write this function yourself because somebody else wrote it for you. And then another advantage is, especially when you're beginning to program or starting out with programming, the functions that are written by experts or people who have multiple years of experience will generally be much faster and better tested than the programs that you write. So if a function exists, you should definitely use it and not write it yourself. Um, Also makes your programs more portable, because if you're using functions in the C standard library, they will always be available to you, even if you're using them on Windows or Mac or some other operating system. Uh, printf, scanf, and POW are functions that we have used already. But you can also define your own functions, as I just said, right? So if you define your own functions, those functions are generally called programmer defined functions. Um, and functions are often called or invoked um, by what is called a function call. So to make use of a function, you actually have to call a function, right? So just like if you want to print something, you want to print some text, you have to invoke a printf function using the printf function call, right? And you obviously can pass it some arguments. In this case, the arguments that we are passing is the text that we want to print uh, and show the user. Um, a function which basically calls another function is basically called the caller. Now, a common comparison or analogy that is often given for functions is what you see in various organizations in different hierarchies of management. So you could think of a program which is written in terms of different functions. So, just like you have an organization, so a boss is kind of like the main function, and he gives orders to various subordinates or various workers. And then what those workers do is they execute the functions that are assigned to them or the tasks that are assigned to them. And the boss does not have to worry about how those functions are executed, right? Or how those tasks are executed. That is the responsibility of the functions or the workers to which those tasks are assigned. And similarly, as you have in an organization, a function can call another function. So if in an organization, a president assigns a task to a senior manager, the senior manager can assign it to a, a manager who can then assign it to a junior manager who will eventually be executing the task. So functions can call different functions. So you have a boss at the top, he could offload part of his work to one worker and part of his work to another worker. And then this worker might have some other worker or some other functions that he can to get the job done. So it works in a similar way for functions. So you have the main method, which can call something like a printf function, and then you might have another function, function 1, which might call two other functions, functions 3 and function 5. So that can happen. We will look at some examples. Now, here is one example which actually shows you a function calling another function. So in this case, we have a printf function, which wants us to print a certain string. And basically, we wanted to print a floating point number with 2 decimal precision. Now, what does this do? Over here, in this argument, we are basically calling an sqrt or a square root function, which is part of the math library. And what this will do is it will take the square root of 900, which I believe is 30. And so what you will get is something like 30 being shown to the user. So in this case, what is happening? The printf function is calling another function which is executing something. So this is something which is allowed. Now, when you are actually using a function from the math.h standard library, you have to include the preprocessor directive for it, because if you do not, you will get an error when you try to call a method or a function from that library. Now, as far as the arguments of a function are concerned, so in this case, the argument of our square root function was just a number 900. But you can give an expression, so you can give your function something which evaluates to a number, so you can give it variables. So we have C1 plus D multiplied by 5, so whatever that number is, I think that's 25. So what you in effect will happen is you will get this function sqrt25. So this is the argument of sqrt. Sqrt will return 5, and basically that 5 will be the argument of the printf function. So when you take the square root, you get 5.0, and 5.0 is the second argument of the printf function. What is the first argument of the printf function? It is this text string that you are passing it. So you are sending 2 arguments or 2 variables to the printf function, and it does something in response. Now, here is a list of all the functions from the math .h library. You have the standard square root method. You have cube root, which basically is something like cube or the third, 1/3 power of a variable. You have the exponential function. You have the natural log. Now, what is the natural log? That's log to the base e of x, also written as lnx. Then you have the log 10, which is log to the base 10 of x. So you have to write log 10 explicitly like log 10x. If you just write log of x, then C will assume that you want to take a natural log. You have absolute value function. You have a ceil function. What does the ceil function do? Well, it rounds up. So you have, when you're rounding off decimal numbers, you can either round them up or round them down. So ceil basically means that you round off a decimal number to the integer which is closest to it, but is not less than that number. So ceil of 9.2 will actually be 10, because 10 is the smallest integer that is not less than 9.2. Similarly, ceil minus 9.5 will give you minus 9, because minus 10 is actually less than minus 9.8. Similarly, you have the floor. Floor you could think of as round down. So it will round it down to the largest integer, which is not greater than the argument. So the floor of 9.2 is 9. You have seen the power method and you are familiar. So these are other methods that you can look at. So the advantage of functions, of course, is that they allow you to modularize your program or break it down into smaller pieces, smaller modules, which make it easy for you to write the program, to think about how to write the program, to use your program, to modify your program, to find errors in your program, and also makes this modular approach, it also makes it very easy for other people to modify your program or use your program as well. So there are lots of benefits that you get by using functions, right? Now, another thing that you want to note about functions is, and we will look at the definitions of the functions in a second, but when you define a function, all function variables that are defined inside a function are what are known as local variables. So they are not visible outside of the function. So if you have my function and you define its body somewhere here. Now inside this you have an integer x. This x will not be visible outside the body of or the definition of the method. So that's something that you want to remember. Most functions have a list of parameters, so they do get something as input and they do generally return something as output. So these parameters, if they are sent to the function, they are known as input parameters. If they are returned by a function, then they are known as output parameters. Most functions have them, but it is not an essential requirement. You can write functions that have no parameters that are input to them or returned from them. And often what happens is main function is in most cases implemented as a group of calls to functions that perform the bulk of the work. So the main function basically is the boss function. And so note, main is also a function, right? You could write the output as, so if it returns an integer like 0, you can write this as int main, and then void basically means that you do not send anything to it. But this main function can assign different tasks to different functions. So you have function 1, you could have another function which could be like printf and something. So it consists of different functions that are executed once or multiple times. So several motivations, I've discussed these. Reusability is a main advantage of this. So if your program is written in terms of functions, it's actually very easy for other people to modify it. Reusability is also a major factor in object-oriented programming languages, which you will study later on. And so it was derived because C is the oldest, so reusability techniques were all derived from C. So the basic object or the idea of reusability was functions in C, but C++ and Java and C Sharp, they introduce even more advanced concepts that make writing programs even more easier than it is with C. Another thing that you want to remember is each function should generally be limited to performing a single well-defined task. So if your program has too many, if you have a function that tries to do too many tasks, then it is generally going to lead to a lot of confusion. You should try to limit one function to one task. This is generally what is recommended. Uh, and if you're doing one task, you should try to use a name that expresses what the function does, right? You should not name your function any random thing. If you want your code to be reusable, if you want it to be easy to work with, the name of the function should generally reflect what the function does, okay? Um, So each program that we have represented or seen so far has at least one function, which is called the main function, right? And main um, is a function that the standard C library actually provides you to accomplish different tasks. Now let's look at an example, because we've been talking about abstract concepts for too long. So now we're looking at an example which basically is has a very simple function which takes the square of uh, an integer number. So the first thing that we do is, when we're working with functions, is we give a declaration, or sorry, a prototype of a function. What is a prototype of a function? Before your main, you write down the name of your function. So in this case, the name of our function is square. You put it inside brackets, you write the semicolon, and then you write int y. So what that means is our function, so we know that the name seems to indicate that our function seems to take the square of something. Int y tells us that our function is going to get or receive an integer argument, and this int basically tells us that our function is going to return an integer value. So the prototype is something similar to the preprocessor directive, right? So the prototype basically tells the compiler, okay, you should expect to see a function which looks like this. What is the function? That is defined later, but this kind of gives the compiler a little bit of a heads up. Hey, you are going to get this function. Now, within that program, what do? We have an integer uh, x which loops uh, 10 times. Our x starts from 1 and goes up to 10. And we are basically printing the square of this integer x. Now, what happens when we come down here? We get a function call. So our program goes and it calls this function. So when it sees square, it says, okay, I have a function call to message to a functions x. And what do? When I see that, I go down here where I have the definition of the function x. Now, what does the function x do? Well, let's look at this. Again, you have something similar to the prototype, except that you do not have a semicolon here. Now, that's in terms of syntax, that's the key difference between your prototype and your definition. So definition does not have a semicolon. You have int square, int y. So this variable, when you call the function square, you get a copy of the variable x. So you don't get the original variable x, you get a copy of it here. This copy, when it comes down here, it is put inside a variable y, which basically returns y multiplied by y. So it just takes the square and it returns that integer value, which then comes back up here and then passes as an argument to the printf function, which just prints it. And so the result of this function is square of integers between 1 and 10. Okay, so again, you have a function call. Function call basically takes you to the definition of the function. The definition basically does whatever it does. It returns something that basically goes inside here, and it goes as the argument to the printf function, which has two arguments, %d, and then it has whatever is returned from this method or function square basically goes in as the second argument, and that's displayed on screen. Okay, and so basically what happens is, because we are putting this inside a loop, our loop repeats 10 times, and so we get 10 function calls, and 10 times we are printing the square of the value of the variable x. Okay, and so with the definition of the function, another thing which is important, so the return statement basically just returns the square value of this expression. So it just returns this expression, which is just the square of what is passed to the function. And I've already talked about the prototype. Again, remember, with the function prototype, it generally needs to be on top before the main function. It needs to tell the program what the name of the function is. It also needs to tell it what the input parameters or arguments are and what the return parameters or output parameters are. Now, as far as the definition of the function is concerned, it generally is, you have in the definition you define, you first tell what type of argument, what type of data does the function return, space, what is the name of the function, and you have parentheses, and inside here you basically fill in the parameter list. So this list, inside the parentheses, you will have the list of the parameters that are followed to the function. In the definition, you should not write the semicolon. And then you have curly braces, and inside you have the main definition of the function, or the body of the function, which basically tells the program what the function is going to do. Now, the function name is any valid identifier. Return value is the type of data that is going to be returned, and so together the return value type, the function name, and parameter list are sometimes referred to as the function header. So again, you could think of this the function prototype as being like a function header. So, and it also goes, or it is listed close or in close proximity to the headers of the function, because your function actually, your main program actually lists them right on top, so near the include directive. So yeah, so that's why you could also call them the header. But yeah, the purpose of the prototype is to do something similar to what the header preprocessor directives are doing, right? Another thing that you want to make sure is that your program actually returns the value that it is supposed to, because if it doesn't, then you could kind of run into problems. Okay. Parameter list. So if you have more than one parameters, you generally separate them with a comma. So you could have parameters So more parameters are generally separated by commas. If you're not passing anything to a function, then you can just write void inside the parentheses. Also, don't write something like this. So if you're going to pass two double variables x and y, don't write something like, if this is your function, don't write something like this. You have to explicitly write double x and double y. Okay, so this you need to remember. Again, do not put a semicolon or a semicolon when you're defining the function. So don't put a semicolon after the parentheses when you're defining a function. Also, one more thing, and this is important. When you are just give me 1 second. So when you're actually calling a function, you're not really required. So let me just come back to this. Sorry, it's kind of confused. So we talked about the function body. The function body basically comes after the parentheses. So after you've written down the name of the function, then your body basically comes inside the curly braces. You generally do not define a function inside another function. And if you try to do so in C language, you will get a syntax error. So do not try to put the definition of a function inside the body of another function. You have to generally define it outside another function. So even in the main function, when we are calling our function, let's say we were calling the square function, we gave its definition outside the body of the main function. We did not define it in here, inside the body of the main function, because that will give a syntax error. Generally use meaningful names for functions. Meaningful parameter names also makes your programs more readable. So if you write your function as function 1, function 2, then if your program is bigger in size, it will become very difficult for the user to actually understand what your program is doing, and it will take them a long time to try to figure out what is function 1 and what is function 2. Might be better to use something like, square or cube or whatever. But these names, with these names, the user does not really have to go and look at the definition of the function or remember things. So generally, it's good to do that. And feel free to write small functions. Small functions, even though if they might be small, it doesn't matter if if your function has 1 or 2 lines, still okay to write small functions. And generally, your function should not have too many parameters. If your function has a large number of parameters, maybe 20 parameters, it's probably better to divide that into 2 or 3 smaller functions, because otherwise it just becomes too much. The user will have a very hard time trying to figure out what the program is doing. Ideally, your function header or your prototype should actually fit in just one line. That's a good way of measuring that, and you're either passing too many parameters to a function. If it crosses one line, then it's probably too big. There are multiple ways to kind of return control from a function, right? Now, if your function does not return anything, then just putting the return statement on the last line of that function would take you back to the program, right? But if it's return something, then you can basically put like return and then maybe put an expression here, or maybe just a number or whatever you want to put. So this will basically return the value of the expression. So it will not return the expression. So if you have an expression like x multiplied by y, it will give you the result of this, put it inside some temporary variable, and it will, that is something that you will send back to the function that was calling you, right? And you've already seen that with most of our programs, we used to write return 0. We said that's good, that's good practice. So return 0 was something that we were writing, and in our main function, we were writing it as int main void or something. So this int basically is 0. So you generally return 0 at the end of your main program. And that generally indicates that a program actually ran successfully. So 0 means that your program generally ran successfully. Now, if you do not explicitly write return 0, your program will still work, right? So your program is still going to work. Even if you do not write return 0. What happens is C generally adds this return 0 on its own, even if you have not written it. Okay. And sometimes programs return something other than 0. So they often also return -1 or some other non-zero value. And that a lot of the times indicates that the program had some problem or it could not execute successfully. So, this is also kind of standard practice. Now, let's look at our second example. And our second example, what we're going to do is we're going to define a function called maximum, and that maximum is basically going to take 3 integers as input, and it is going to return the maximum value of those 3 integers. So it's a simple function, but it allows us to accomplish something nice. So let's look at this. So the first thing that we do is the function prototype. Again, look at the function prototype. You have definition. So the name of the function, because you are passing 3 integers, int x, y, and z. So it takes 3 integers as input, and then it is going to return an integer, right? So this function prototype just gives us this information. So it tells the compiler, okay, this program contains a function called maximum. It takes 3 integers as input and it returns 1 integer when it's called. Okay, so inside the body of the main, what do we have? We basically ask the user to enter 3 integers. Then we take those 3 integers and then we pass them to our function. So we are calling our function maximum and we pass it the 3 integers. Now, what is the definition? It's given on the next slide. So in the definition, we take integer x, y, and z. We assume that x is the largest or x is the maximum of the 3. And then we have 2 if statements. If y is greater than max, which actually is x, then we put max equal to y. So if y is larger than x, then max becomes equal to y. And if it's not larger than x, then x remains the maximum number. Then we check if z is greater than max. And if z is greater than max, then max becomes equal to z. Otherwise, it remains unchanged. And then we return max. And max is an integer. So our return value or return data type is also an integer. So we go back and then we get whatever maximum value we have. We print that here, and that is an integer value. So we're going to print that out. Okay, so a simple program. So these are just three sample demos. So you can see in this case, it picked 85, which was y as the maximum number. In this case, x is the maximum number, and in this case, z, which was last one, is the maximum number. Okay, now let's talk a little bit about a function prototype in C, and why do we actually need a function prototype? This is a feature which originally was not part of C, and so it was borrowed from C++, which came much later. So this was kind of like an afterthought. People did not think about this initially, so you were not required in older versions of C to write a prototype at the top of your program. But what basically it allows you to do is it allows the compiler to validate or double check that function calls are correct, right? So it allows the compiler to actually check that, okay, is the program actually passing the values that it is supposed to pass to a function. So in our maximum function, we have three integers being passed to our maximum function and then one integer being returned. So the prototype basically allows the compiler to check whether this is actually the case. Now, if instead of an int we end up returning a float, then the program will do something about it. It will either convert this integer to a float, or if it cannot do a type conversion. So if you're in a situation where two types cannot be converted into each other, or conversion will result in some errors, then the compiler may throw an error. So the prototype kind of tells the program what to expect, and then act accordingly. Okay, so early functions of C did not perform this kind of checking. And the problem with this was that if you did not do any checking, then what used to happen was you could basically get fatal runtime errors or non-fatal errors, which cause very difficult to detect problems. So that's why this is something which was added later on, and it actually is quite useful. So this is our prototype for this particular case. So we have an int being returned from this function, and then three integers being sent as parameters to this function, right? And yes, notice that this function prototype is exactly the same as the definition, because if it's not, if you use different types of variables in the definition than you do in the function prototype, then that will definitely cause some errors, because the program will say, no, you should be sending these type of arguments. So the definition and the prototype should actually have the same types, right? Now, you are really not required to specify the names of the parameters inside function prototype. So you could have written this as int max int int int. So you did not have to write down the names of the three variables as you have done in your example. So this is what you wrote in your example, but you did not have to provide the names of the variables in the prototype, because the prototype, all it needs to know is, all right, what type of arguments are being passed and returned and how many are being passed, right? It does not really, it is not concerned with the name of the parameters. However, it is recommended that you do include the names of the parameters in the prototype, because if you do not, but if you do, then it actually makes the program much more easier to read and understand. So people generally recommend writing the names here, even though they are not required. And then of course, if you forget to put the semicolon at the end of the function prototype, that will result in a syntax error. So a function that does not match the function prototype, a function call. So if you call a function and your call does not match the function prototype, then that will give you a compiler error, right? So for example, if we had written something like int void maximum int xyz, the compiler would generate an error because, you know, void was not, we're actually returning an integer. So this conflicts with our prototype, and that would have caused a compiler error. Now, the final concept that we're going to cover, basically argument coercion and how things are converted. So let's say you pass an argument which is of a different type than the one that the function expects. One example is the square root function of the math library. What I want to say is, in the math library, all functions return, and I think they also, their inputs are supposed to be doubles, right? So all parameters of all functions inside the math.h library are basically of type double. Now, what actually happens in this case is we are passing it an integer. So we have sqrt4, but the return value is 2.00. So why did that happen? Well, what happened was, even though you passed it an integer 4, what the program did was it converted it into a double. So it converted this into 4.0, and then it took the square root. And with converting an integer into a double, you're just adding some zeros. So that is not a problem. That generally is going to happen and will not cause you any problems. You will see problems when you try to convert floats into integers, because if you have a number which is 4.25 and you convert that into integer, well, then you're going to get rid of these. So that will cause problems in calculation. So that is something that you need to be careful with. But you know, going from an integer to a float is not a problem, because you just have to add zeros. You don't really need to add decimal values because they don't exist. So conversions generally follow C's usual arithmetic rules. So, you know, if it is a integer, it will automatically be converted into a float. But if it is a float and you're trying to convert it into an integer, then you will lose some information, and that may cause you some logical errors at the very least. Okay. So in the sqrt example, the int was automatically converted to a double without changing its value. However, if we try to convert a double into an int, that truncates the fractional part, right? So it gets rid of the fractional part. So if we have a number 4.23 and we try to convert it into an int, well, it will get rid of this part. This part will be eliminated. You just have 4, and again, depending on what you're trying to do, that may or may not cause problems for you, right? Uh, Another issue might be that if you're trying to convert, let's say, a long integer into a short integer, right? So a long integer can actually store very large numbers. If you try to convert, or if your function call actually takes a long integer and converts it into a short integer, well, that may also cause loss in information, because your long integer might store something like 2 million something something something, a very large number, and when you go into a short, then it can only store a value like 65,000. uh, that can also cause problems, so you have to be careful about these, right? um, just a couple of minutes over time. Just me just finish this slide, and we can then look at some practical examples next time. uh, so if one of the values is a long double and the other values, okay. Okay, let me just remind me to cover these slides again next time as well, because I'm going through them a little fast. But if somebody has doubts, I can cover them. So if you're working with mixed type expressions, uh, what happens is it converts all data types. So if you have an expression which involves an integer and a float, and then maybe something else, what it will do is it will convert the integer variable to the float variable. So it converts things into the highest type of the expression, and so a float is normally considered to be a higher type, right, because it has more information. So before doing the calculation, it will actually convert it into a float. um, and that should work. So normally you go in this direction. So this is, if you're looking at just integers, this is the simplest data type char, and then this char, basically these are the highest data type. So unsigned long integer. So this is a very long integer. So you have char, short, unsigned, short, then integer. So this is the hierarchy. So you can convert a char into a short if needed, or a short into an unsigned short and an integer. Similarly, you can go the same direction for float as well. As long as you're going in this direction, that is not a problem. The problem is when you actually have to come back into this direction. So if you try to come down, you are going to lose information, and that will cause problems. So you have to be a little careful about that. For example, you're trying to take the square of this number 4.5, and so square 4.5 returns 16, not 20.25, which is the actual answer. And why is that? Because our variable square, or sorry, our function square is defined as something like int x. So it expects an integer. So if it gets a float 4.5, it will convert it into 4, and then it will take the square. And that obviously causes problems. Now, if this was something like square float x, and it received an integer, that integer would be converted into a float, and you would get the correct answer, because you were not losing any information. So these are the sort of things that you need to be careful about. That's all we're trying to say here. Although the slides kind of contain a lot of text, this is not. This is generally an easy concept. Um, so converting from a higher data type in the promotion hierarchy to a lower type. So yeah, this is something which may cause some warnings at least, but you have to be careful about how things work. So yep, so I think this is probably a good place to stop, um, and we will look at a hands-on demonstration of this in the next lecture. Thank you so much for joining. I have another lecture, so I'm going to head out soon. I will upload this recording to YouTube. I did not have time to record the lecture, so I'm going to upload the recording to YouTube as well, and I will share the link with you.